Okay, so let's solve this one. This is a good one, by the way. 0 to pi by 4 log of 1 plus tan x. This is a good one. So we will again start thinking on first. I mean, as soon as I notice a question in definite integration, my first approach should be whether it can be directly integrated or not. Now, this is log of 1 plus tan x. And we haven't had any function in which there was a, I mean, this is a composition of function. Inside logarithm, we have put tan x, 1 plus tan x, in fact, right? So this is not going to be easy integration if we go in terms of indefinite only. So now we will think about using properties. So using properties, I told you that there are four most important properties. And in this case, your third property is not valid. If, okay, so my bad. Yeah, so your third property is only valid in case of piecewise function, as we have discussed in the last class. Piecewise. Your eighth property is only valid when the limits are minus a to a, right? So only, I mean, only two conditions left are fourth, right, and sixth. And I told you that we will use fourth first rather than sixth, right? In all most of the questions, fourth will be used. In some questions, sixth will be used when you are not getting answers from fourth, right? But there are very selective questions which will use sixth property, so we don't need to worry about that. Yeah, so in this case, let's start with first giving the question, first equation, then we will apply property 4. Apply property 4, right? So after applying property 4, we know that we have to convert x to a, which is lower limit. Lower limit in this case, we know lower limit is 0, right? So x changes to 0 plus pi by 4, which is pi by 4, lower limit plus upper limit minus x, right? So it means that the integration will not change. The limits will be same, 0 to pi by 4, and the integration will change to log of 1 plus tan of pi by 4 minus x, right? In place of x, we will write pi by 4 minus x dx. Now we can open tan of pi by 4 minus x, right? This is tan a minus b. We know the formula for tan a minus b, which is tan a minus tan b divided by 1 plus tan a tan b. So in this case, the question becomes important because it is also using trigonometric identity. So can you simplify, open this and simplify using this property? This is tan a minus tan b, 1 plus tan a tan b, right? A here is pi by 4 and b here is x. So it should be tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. And pi by 4 is 45. So tan pi by 4, that is tan 45, is 1. So I can simplify this whole expression as 0 to pi by 4. This is log, and this would be 1 plus this would be tan pi by 4, which is 1 minus tan x divided by 1 plus tan pi by 4 into tan x. We know the value of tan pi by 4, it is 1. So the equation reduces to I is equals to 0 to pi by 4 1 minus tan x divided by 1 plus tan x. This can be further simplified. I am showing it here. It can be written as log of, we can take the LCM as 1 plus tan x. So this would be 1 plus tan x plus 1 minus tan x. Right? Tan x gets cancelled out. So this becomes log of 2 upon 1 plus tan x. So this becomes log of 2 upon 1 plus tan x into dx. This is my second equation. Right? Now I can add 1 and 2. We can add the first equation and the second equation. Let's see what we get. So adding 1 and 2, this becomes 2i on the left hand side, I plus I. And on the right hand side, first equation is 0 to pi by 4. As you can see that the limits are same. So I can directly add the expression, which is log of 1 plus tan x from the first equation plus log of 2 upon tan 1 plus tan x from the second equation. Into dx. Now this is log a plus log b. Log a plus log b can be added by log of a into b, right?
Sir,
Yes, Chavez.
can you just scroll up?
Yeah. Is it okay?
Yes.
Please tell me whenever you are done. I'll give you time to write this, Chavez. Just wait a minute. Just understand the steps first. First, we have given the question an equation name 1. Then we have used property 4, which is change x to a plus b minus x. And we have simplified the whole thing using this formula. Right? After simplification, we got our second equation.
Sir,
Now we are adding 1 and 2. Okay.
sir, here why we are adding 1 and 2?
So we are adding 1 and 2. Sorry.
So like why we are adding 1 and 2?
Why are we adding 1 and 2? That's the question. I'm not able to hear you properly, actually.
Yes, sir, like why we can't simplify that equation to?
Yes, we can simplify the equation further, but we are adding the equation so that we get this part cancelled out. I mean, the problem here is log and tan x. I mean, tan x inside log. If it would have been log x, we would have been integrated this. If this would have been simply 1 plus tan x, we would have been integrate this. But it's log of 1 plus tan x. That is the problem. That is why we are adding both of them, so that now you will see after adding, we will cancel out 1 plus tan x easily, right? We could have also done it here written like log a minus log b. This could have been written as log of 2 minus log of 1 plus tan x. That would have been correct as well. Well, this is your choice. You want to do it like this, or you want to, I mean, in that case also we would have to add. After adding only we will get the final answer.
Okay, sir.
Yeah. So this is log a plus log b. Now we can use the formula log A plus log B, obviously with the same base. And we can see here the base is E for both of them because we have not written it. So log of A plus log of B can be written as log of AB, right? So the same formula I'm going to apply here. 2I is equals to 0 to pi by 4. This becomes log of 1 plus tan x into 2 upon 1 plus tan x. Now you can see that this 1 plus tan x, 1 plus tan x gets cancelled out. So we are only left with log 2, which is a constant. Log 2 is nothing but a constant. You can take that out. So this is log 2 outside. This becomes x. The integration of 1 is x from the limit 0 to pi by 4. You put the limits, the answer is pi by 4. It implies that 2I is equals to log of 2 into pi by 4. You can take that to the right hand side. So I becomes pi by 8 log 2. So in some of the questions, you may have to simplify the question itself, right? So use these properties, simplify, and then add. Please note down the question. If somebody is noting down, just raise your hand. Otherwise, we will move on to the next question.
So,
Yes, Shavis?
like, how will we know which property we have to use
That is what we are
these
doing,
questions?
Shavis, for the fifth, sixth question. In every question, I have the same thought process. I have told you which steps should we check. So second is, I told you, no, in the previous question as well, in the, or I mean, in other questions that we have solved in the previous class as well, that third property will be used in piecewise functions. Eighth property will be used when the limits are from minus a to a. I mean, these are the four most properties used. I mean, most used properties. So, and these are four: third, fourth, sixth, and eighth. Third, fourth, sixth, and eighth. So third will be used in case of piecewise. Eighth will be used in case of when limits are minus a to a. Okay.
Yes.
And fourth and sixth, I mean, in most of the cases, fourth will be used. Sixth has some selective use cases. I will show you all of those use cases. And also tell you how can you judge whether we had to go through this or not. Okay, let's solve this one. This is also a good question. Also, please mark example number, just a minute, 36. Example 36, page 346, NCRT. Page 346, example 36. This is a good question. Has been asked, had already been asked in the CBC exam. So we will also solve this. No, you guys solve this. And in the next class, you come if you have any doubt. Now let's solve this question. You guys have to try this one. And please also solve miscellaneous exercise. Miscellaneous exercise for this chapter is very important. I mean, there are a lot of questions which can be asked from miscellaneous and has already been asked in the previous exams. So don't miss that exercise. You will face problems, but please feel free to ask me. After today's class, our syllabus for integration will be over and everybody has to solve all exercises. Please focus on miscellaneous as well. You guys have to solve 7.11 and miscellaneous exercise by the time you come to next Monday's class.
Seven,
And yeah,
7.1 all questions.
yeah, 7.11 all questions, because we will cover the only other property which was left in the last class today, and that which is property number 6. So we will cover some questions, I mean, one or two questions from that also. But yes, we are able to solve most of the questions. We should be able to solve most of the questions from definite integration now. But don't worry, if you are facing problems, please feel free to reach out to me and come with your doubts in the next class. Now let's focus on solving this question. This is 0 to pi by 2, 2 log sine x minus log of sine 2x. So this is a very good combination when log and trigonometric functions combine. And I think you should be able to know all the trigonometric identities as well as logarithmic identities. We have already covered all these identities in differentiation as well as integration. I mean, logarithmic has been covered in differentiation, and trigonometry, though, we have been covering for 2, 3 chapters now. In fact, in most of the chapters, trigonometry is used. To solve this, I would suggest hint would be to first simplify the logarithmic terms. You can take this 2 inside to the power of sin x, right? So this 2 can come inside log as log of sine square x. And then this is log a minus log b. So please try to simplify the expression first, I will suggest. And then it would be better to apply the property. You have 2 minutes. Please, everybody start solving the question. Anyone with the answer yet?
Sir, I'm doing.
Are you done? You're doing okay. Shahid, Mahmuddin, Faiza, Austin. Please, everyone, try to solve this one. No? This is a good one. So we don't know yet which property to use. Let's first just simplify the whole term, right? So we can write this as log of sine square x, right? So this 2 will go inside. And then this will be log a minus log b, which is log a upon b. So can I write the whole expression like this? Are you guys with me by this? In the numerator, we have
Yes, sir.
written sine square x, and in the denominator, we have written sine of 2x, right? Now we can open sine 2x. What is the formula for sine 2x? Anyone?
2 sin x cos x.
2 sine x cos x. So I can further, oh, sorry, my bad. I have written the limit pi by 4. It's not pi by 4, it's pi by 2. Yeah. So it is 0 to pi by 2. This will be log of sine square x divided by 2 sine x cos x. You can cancel 1 sine x. So in the numerator, it is only sine x now. And in the denominator, it is 2 cos x. Sin x upon cos x can be written as tan x, right? So this is nothing but I is equals to 0 to pi by 2 log of tan x by 2. Cool. So the original question, which was written as 2 log sin x minus log of sin 2x, can be actually
Sir,
reduced
we
to
also got
log.
this.
You got the answer? What's the answer?
Sir, I also got that.
Acha, okay. So log of tan x by 2. Now we have to decide. So first of all, we have to simplify the expression. Now we can decide which property to use. Again, the same thought process. Can we use third here? Is it a piecewise function? I mean, this is clearly not a piecewise function. Logarithmic is
Yes.
only defined by one expression, right? And then there is no, I mean, thought on minus a to a as well, because the limits are 0 to pi by 2. So we are left with only two properties, either fourth or sixth. Now, we have solved a lot of questions on fourth, and you should understand how we are using fourth. We want to use fourth like we will give this equation first, and we will form another equation using a plus b minus x. So think about if I change x to a plus b minus x, what effect or what change will it bring in the original equation? Think like that. And then you will be able to get
Sir, you
when to
can
use
cancel.
fourth or not. Yeah, it will get cancelled because tan x, and then if we replace x with pi by 2 minus x, it will become tan of pi by 2 minus x, which is what? Cot x. And the expression is inside log. So if you add log a plus log b, it would be log ab. Again, the same thought process that how we have solved the last question. So you can simply check whether to use fourth property or not. I mean, we don't have anything special for sixth property, but we do have something special for fourth. Understand this point. Fourth property, we can see from 2 3 steps away that we are able to close in the question, right? So understand when to use fourth property. We will not be able to understand when to use sixth property, but we can surely understand. I mean, in a lot of questions, 80%, 90% questions, we will be able to judge whether to use fourth or not. And if we are not successful with fourth, then we will move on to sixth. This is the approach. So now we can see that if we use property fourth, it will get cancelled out in the end because tan x into cot x is 1. Okay, so using property fourth, let's solve the question now. Using property fourth, we can change x to lower limit plus upper limit, which is pi by 2 minus x. So pi by 2 minus x will be 0 to pi by 2. This will be log of tan of pi by 2 minus x divided by 2 into dx. This will become cot x. Tan pi by tan 90 minus x is cot x. Because tan and cot are complementary pair of each other. Complementary pairs are those which changes 90 minus x to the other function. Like sine and cos are also complementary. Sine 90 minus x is cos x and cos 90 minus x is sine x. Similarly, tan 90 minus x is cot x and cot 90 minus x is tan x. That is why they are said complementary. Sec and cosec are also complementary. But this is the only pair which is also reciprocal and complementary of each other. What am I saying? I'm saying that sine 90 minus x is cos x, but sine x is 1 upon cosec x. So sine has a reciprocal relationship with cosec and sine has a complementary relationship with cos. But in case of tan and cot, both are reciprocal as well as complementary pair of each other. So adding 1 and 2, we get 2y on the left hand side. And on the right hand side, we got 0 to pi by 2 limit for both of the integration. And the first expression is log of tan x by 2. And the second expression is log of cot x by 2. Which will be log AB. Log A plus log B will be log AB. So this can be written as 0 to pi by 2 log of tan x into cot x divided by 4. Now tan x and cot x is 1 because tan x is equals to 1 upon cot x. So you can basically simplify that to another expression as 0 to pi by 2 log of 1 by 4 dx, which is again a constant, right? This is also a constant. And this can be further written as, so you take this constant out, right? And you can write this as 4 to the power minus 1. 1 upon 4 can be written as 4 to the power minus 1. And that minus 1 can be taken outside. So this will be minus log 4, 0 to pi by 2. I told you while solving the logarithmic functions that these two properties of logarithm are very important. One is log a to the power m and b to the power n. So we are saying that we have, this is an input a which has power m and this is base b which has power n. So these powers can be taken out with this rule that power of input will be in numerator and power of base will be in denominator, right? So these two properties are very important in case of log a plus log b. I mean, we know that log a minus log b is just nothing but we just have to add division in that. Log a plus log b is equals to log of ab. So these two properties for logarithm are very important and we can see that we are repetitively using them. So this will be,
Sir.
yes.
So how is it minus?
Because this is log 1 by 4, no? So this can be written as log 4 to the power minus 1. 1 by 4.
Yes, sir.
And then minus 1 can be taken outside. I mean, this rule applies for both ways, no? If you have powers, then you can take it outside, and if you have any number outside, it can be gone inside, right? So this will be okay. So this will be x, right? Integration of 1 will be x, and then we will put the upper limit minus lower limit. So the answer will be pi by 2. And I'm writing this directly, minus pi by 2 into log 4. After solving this integration wala part, you will get pi by 2. So the final answer in this case is minus pi by 4 log 4. Minus pi by 4 log 4. right? Any problem, please feel free to ask. Okay, chalo, let's solve this one now. चलो पहले मैं ही बनाता हूँ क्वेश्चन. So this is a very easy question. I want you guys to understand eighth property. That is why we are forming this function. So the limits are from minus pi by 2 to pi by 2. Okay. And then one function is sine square x plus cos x, right? Plus x cube plus tan x plus sine x. Right? So this is the whole function. We can also use plus minus any number of times. What am I saying here is that, yeah. And we want to find this I in this case. I is the value of this integration. We want to find I. Now we can very clearly see that the limits are from minus a to a, minus pi by 2 to pi by 2. So in all these cases, first I will go to the function and I will try to understand the function, whether the given function is an even function or an odd function, right? So first of all, what am I going to do is I will take them individual. I'll take minus pi by 2 to pi by 2 sine square x dx. I'll integrate this separately. I'll integrate cos x separately. I'll integrate x cube separately. Then I'll integrate tan x separately. Definitely I can do that, right? And putting the limits. So what is the impact of doing this is that if you solve individually every part, then you will be able to check every part individually and get the answer using even function and odd function wala trick. So individually we have to check all these 5 functions as odd and even. So let's start first with sine square x. Let's take sine square x as the first function. So consider how to solve this question. So consider first function as f1x, which is sine square x. Now to check even and odd, replace x with minus x. So your function will become f of minus x, which will be sine minus x whole square, right? Now we should know the formula of this. This is minus sine x. Sine of minus x is minus sine x. So sine x individually is an odd function because x is coming out of the whole function, right? But this is sine square x. So after we take square, this is again sine square x. Minus sine x whole square is sine square x only, which is our original function. So it has no effect of changing x to minus x. That is why we can say that this given function is an even function. And in case of even function, we know how to use our property. So I will come to using the property in a bit, but before that, let's find out the type of all these 5 functions. So take this cos x as f2x, second function, change x to minus x. I mean, go through the procedure of checking whether this function is even and odd. And every time you have to do the same. Change x to minus x, check whether this has any effect on the original function or not. Now we have already written this. We have also solved this, that cos of minus x is nothing but cos x. So this is an even function. Can you tell me about x cube? If I change x to minus x, whether minus will come outside of the whole function or not? How is x cube a function? I mean, is it a odd function or an even function? X cube. We have also written this, just so you know. What about tan x? Yes, Austin, correct. Odd function. X cube is an odd function. You guys can check. You change x to minus x, your whole function becomes minus of x cube. So x cube is the original function, right? Similarly, tan x and sin x are also odd function. We have already checked this. Odd function. And tan x is also odd. I'll show you. I mean, sin x is odd. We can check this from here. See, it was square. That is why it was even. If it wasn't square, then it was minus times of sin x, which was an odd function. Now let's also check tan x. So for checking tan x, we can write it as, you can write tan x as sin x upon cos x, right? So if I change x to minus x, this will become sine of minus x upon cos of minus x. My bad, just a minute. We should write minus x here. Now we know sine of minus x would be minus sine x and cos of minus x would be cos x only. So all of this becomes minus of tan x, which is minus of the original function. So this is also an odd function. Just write them. These are some basic functions. X, x cube, x to the power 5, all the odd powers of x in a polynomial are considered as odd function. You can simply check the reason also. Minus to the power odd is minus. And all the even powers of x are even functions, right? So now we can apply the rule that minus a to a fx dx would be either 0 to a twice fx dx if fx is even, and it would be 0 if fx is odd. So in case of all the odd functions, we can just directly remove the answer. So this would be 0, third part, because this is odd. This fourth part will also be 0. Right? So third, fourth, and fifth will be directly cancelled out, and we just need to solve first and second part. So it implies that I is equals to twice of 0 to pi by 2 sine square x dx plus twice of 0 to pi by 2 cos x dx. We know how to integrate cos x. That we can do directly because we have the formula. And we also know how to integrate sine square x. Can anybody tell me how to integrate sine square x? We have already done that in the class. Anyone? Integration of cos x, so we already know. Sine x. 0 to pi by 2. Yes. Sorry. 1 plus. Is it 1 plus or is it 1 minus? Yeah. So 1 minus cos 2x by 2. And now we can directly integrate this. We know the answer already. So this 2 gets cancelled out by the way. So this is nothing but I is equals to the integration of this is one integration is x minus cos of integration of cos is sine, but I mean it is not just x, it is 2x. So we will also divide it by 2. Only this expression sine 2x, because I mean we are only integrating cos 2x right now. So 2 will be with cos 2x only. And this can be written as sine of pi by 2 minus sine of 0. Sine pi by 2 is 1, sine 0 is 0. So the whole equation becomes 1, right? So this is pi by 2. I'm also putting the limits here. Minus sine of 2 into pi by 2 is sine pi divided by 2. This is the upper limit. Minus 2x is pi, right? If x is pi by 2, then 2x is pi. So that is why sine pi. Minus lower limit 0 minus sine 0 by 2. Plus this is 2 into 1, 2. Sine 0 is 0. Right? Sine pi is also 0, by the way. So this is nothing but pi by 2 only. This is 0. This is, I mean, this is pi by 2. This is 0. This is already 0. This is also 0, right? This is also 0. Right? So this is nothing but pi by 2 plus 2. That is how we can use our eighth property. Just have to check whether the function is even or odd. Sure, let's solve this one. Everybody has to solve this. And okay, so I think we are on question number 4, I guess. Yeah. quickly. Everybody has to solve this quickly. You can see that the pairs are complementary. So if you apply x to a plus b minus x, fourth property, you will get the results, some results. Please quickly solve, everyone. Anji, anyone? Apply the property 4. I'm solving it quickly. I mean, you guys try solving it. I'm just giving you some hints, like what should be the next step. So if I apply property 5th, property 4th, so it will change to x changes to pi by 2 minus x. So this will become sine pi by 2 minus x. This will become cos pi by 2 minus x. This will become sine pi by 2 minus x. And this will also become cos pi by 2 minus x. So I'm just writing the final term. So this will be cos x. Sine 90 minus x would be cos x. Minus cos 90 minus x would be sine x. Divided by 1 plus, this will be sine 90 minus x would be cos x. And then this would be sine x. This should be your, after calculation, this should be your second equation. This is our first equation and this is our second equation. Now we can add 1 and 2. Limits are same, and if you observe, denominator is also same, so you can directly add this. If you add it, what did you get? Hanji, anyone? Did you guys get it? Did you guys reach to the equation 2 first of all? If not, please feel free to ask me. We have just applied property 4, which is change x to a plus b minus x, lower limit plus upper limit minus x. Guys, अभी तो बहुत ही सिंपल है, मतलब तुम कर क्या रहे हो मेरे को समझ नहीं आ रहा. Can you add 1 and 2? You get 0. No? After using property 4th, we reach to here, and if we add 1 and 2, then we reach to 0. Because denominator is same, 1 plus sin x cos x, and if we add numerator, this is sin x, this is minus sin x, this is cos x, this is minus cos x. So we get 0. And the integration of 0 is also 0. I mean, it should be a constant, but it is 0 in this case. Please check the answer for this question. Do anyone have NCRT? Austin, do you have NCRT right now? Please check the answer for question 15 from exercise 7.11. Question 15 from exercise 7.11. If somebody can confirm this answer, please. Austin, Chavez, Shahid, Tharif, Humamuddin, any one of you. Exercise 7.11, question number 15. Guys, Chavez, बताएगा यार इसका आंसर फटाफट चेक करके एक बार. Guys, am I audible? So Austin, please tell me the answer for exercise 7. Acha, okay. Chavez, do you have the NCRT? Any one of you having NCRT right now? Please raise your hand. Tharif, please check question number exercise 7.11, question number 15 answer. And please confirm it, whether it is 0 or not. I think it should be 0, yeah.
Yes, sir. Yeah.
Okay, cool. Okay, let's solve next question. Fifth one. This is a good question, by the way. And possibly will be the last question of the class today. So you guys try this first. We only have 4th and 6th property to use here. You can see that. Neither the function is piecewise nor the limits are from minus a to a. So we only have fourth and sixth. Now what happens when I use fourth? It becomes cos of pi minus x. What is cos pi minus x? Can someone solve this expression, cos pi minus x? What is cos pi minus x? Cos pi minus x? Anyone? Wow. Guys, how would this go? I mean, without trigonometry, so we are nothing in 12th maths. 12th maths, mein to we will have to use a lot of trigonometry. Cos pi minus x is, guys, minus cos x. Okay. So if you apply property fourth, it becomes log of 1 minus cos x after solving. Now, is it helping us? You guys have to think about it. So I would say first apply property fourth. First apply property fourth. I've already told you guys the trick how to check cos of pi minus x. कुछ भी मतलब cos pi minus x or cos 3 pi minus x, cos 2 pi, anything. Using fourth property, we move on to 0 to pi log of 1 plus cos of pi minus x, right? Because we will have to change x with 0 plus pi minus x, lower limit plus upper limit minus x, right? Now, this is minus cos x. This becomes 0 to pi log of 1 minus cos x dx. Now, if you take this equation as first and this as second, and if you add them, so this will be 2i in the left hand side. This will be 2i in the left hand side. And in the right hand side, it should be 0 to pi. And this will be log a plus log b, which is log of ab. So it should be log of 1 plus cos x into 1 minus cos x. It should be 1 minus cos square x. Log A is this 1 plus cos x, B is 1 minus cos x, AB will be 1 plus cos x into 1 minus cos x, which is A plus B, A minus B, A square minus B square. This should be 1 minus cos square x. Now what is 1 minus cos square x? Sin square x. Right? And you can take 2 outside of log because this is the power of sine. So we can actually write this as take 2 outside log of sine x, because sine x has power 2. So I'm taking that power outside. Which implies that we are actually calculating 0 to pi log of sine x. But you can still see we don't know how to integrate this. The same problem, right? The same problem, which is log, a trigonometric function inside log. So we have simplified the expression, but we are not able to actually, yeah. So we are not, but we are not able to actually solve the problem. We have simplified the expression, but we are not able to solve the problem. By the way, this is the same example that I have told you to complete. But let's solve this example. So this question and example 36 is same now. It is just that they have given example 36 in a different form, right? Now, to solve this, as we know that we have already used property 4, and if we use property 4 again, then this will be log of sine pi minus x. Sine pi minus x is sine x again. So it won't change the question much. Now we know that we have to use property 6th. My bad. I'm going to write this 6th only. So now we will use property 6th. Because fourth property is not, we can't use fourth in this case now, right? Now this is a very good question, by the way. This has already been asked in the question, I mean CBSE board exams. So property 6 says, first of all, property 6 says, if you have, which is, I'm going to write here, property 6 says, so for 0 to 2a fx dx, you can write this as 0 to a fx dx minus, sorry, plus 0 to a f of 2a minus x dx. You can also simply check the property in this section only. Yeah, this is the sixth property. 0 to 2a fx dx can be written as 0 to a fx dx plus 0 to a f of 2a minus x dx. Now, this seventh property is the extension of sixth only. So we don't have to remember seventh property. Rather than that, we can only remember sixth and use sixth accordingly. Yeah, so I'm using the sixth property. I'm writing I is equals to 0 to, this is 2a, right? So this can be written as 2 into pi by 2, because this is pi right now. Right? So this can be written as 0 to a, which is 0 to pi by 2, right? Fx dx, which is log of sine x dx, plus again 0 to pi by 2, log of sine pi minus x, 2a minus x. We have just talked about it, that what is sine pi minus x? Sine pi minus x is nothing but sine x only. So this is also sine x, right? Log sine x plus log sine x, 2 log sine x. Which is basically the seventh property. Seventh property could have given us directly this, but it's okay. For that we also need to check this part, right? So this I can be written like this, right? But still, we are not able to solve the question. You can see that, right? Now we have to approach. Either we can go to property 4, right? We can go to property 4th, and then we can apply. I mean, then we will think about property 6, or we can go to either we can go to property 4 or property 6, right? But property 4 can be used here. You can, if you see, because sine of pi by 2 minus x will be cos x, right? And then we can think about solving that part. So use property 4 again. So this is a question which is very important because this includes these properties again and again. You have to simplify the expression further. So change this to 0 to pi by 2. This will become log of sine of pi by 2 minus x. Upper limit plus lower limit minus x, which is cos x. Right? Now adding 1 and 2 again. This becomes 2I is equals to 2 times. You can take 2 common. 1 is 0 to pi by 2. This becomes log of, so 1 is log sine x. 2 can be taken out common. This becomes log a plus log b, which is log ab. So I'm writing it directly as log of sine x into cos x dx. Using the same properties again and again of logarithmic, property 4, property 6, right? This 2 can be cancelled out. This becomes I. Now, this can again, if you see, this can again be written as sine 2x upon 2. I mean, if you multiply the numerator and denominator here by 2, this becomes 2 sine x cos x upon 2. And 2 sine x cos x can be written as sine 2x. So this can be written as 2 sine x cos x divided by 2, which is log of sine 2x divided by 2. Now I can again simply change this expression into a single expression. How? I'm using a substitution here. I'm substituting 2x. Now you will see why we are doing this. If we substitute 2x as t, which means 2 times dx is equals to dt. So dx can be replaced by dt by 2. And you also know the limits. If x is 0, then t is also 0. If x is pi by 2, then t is also pi. So this becomes log of sine t divided by 2. This becomes dt by 2. And the limits are from 0 to pi. Right? The limits have changed. And the question can be actually written as this will be I is equals to 0 to pi log of, okay, this is 1 by 2 outside. Am I correct? Yes, I guess. Just a minute. Yeah. So this is nothing but I is equals to 1 by 2 log of, this can be written as sine t minus log 2 into dt. So this is nothing but 1 by 2.
Sir,
Yes.
can you spell?
Which part?
Just the above part.
Sorry, Shavis, which part?
Sir, before substitute 2x is equal to t.
Okay, so when we have substituted 2x is equals to t, first we try to also substitute dx. So dx can be substituted as dt by 2 from the same equation, right? And also I have changed the limits because these were limits for x. Now we are changing x to t. So if x is 0, then t is also 0 because t is equals to 2x. And if x is pi by 2, then t is pi. So the limits are from 0 to pi. Log of sine 2x becomes t, right? And dx become dt by 2. I have put all the things in this step. And after this step, I have taken 1 by 2 outside. The limits are from 0 to pi. This is log a minus log b. Log sine 2. So log sine t minus log 2. And now I'm just solving this part. Okay. You can see that this is the original I. This was the part which we wanted to solve. Okay, just give me a minute. Yeah, so come to this part. Yeah, this was I, 0 to pi log sine x dx. This can also be written as 0 to pi log of sine t dt. I mean, we have not changed the function, right? So this is the same part, right? So this is
Yes.
nothing but I actually. This can be written as I is equals to 1 by 2. This part is the same that we have been calculating, and this can be done very easily because this log 2 is constant. This becomes x, integration of 1 becomes x from the limit 0 to pi, right? And this will be, so you can take this I by 2 to the left hand side. This becomes I minus I by 2 is equals to minus log 2 divided by 2, and this is pi minus 0, which is pi. So I minus I by 2 is I by 2 is equals to minus pi log 2 divided by 2, which implies that I is equals to minus pi log 2. So sixth property basically is used in this question and in one or two questions of miscellaneous. Sixth property do not have many use cases, but this is the most important question which you should know for sixth property, right? Please try to see what we have done in the question. Observe the whole question because this is a big question. First, we have applied property fourth. From property fourth, we have reached to a simplification. So basically, we wanted to integrate 0 to pi log of sin x, right? Then we have used property sixth on this because property fourth was not useful in this case, which changes the equation to this. We have used property fourth again, and after using property fourth, we have simplified the expression into this. And here we have used substitution. Substitution led us to the same I which we were calculating. And with the help of that, we have tried to calculate the whole value of I. Chalo, now homework is remaining 7.11 and miscellaneous. You have 3-4 days. Please try to solve all the questions and come with your doubts in the next class. We will first take doubt and then we will start area bounded by curves. We'll hardly take 2 classes to complete area bounded by curves. So